This slideshow will show a process discovered by Carlos Linnaeus, a man who observed plants opening and closing their flowers during different times throughout the day, creating a floral cloth. This experiment begins with a potato being left in the dark. After several weeks, the potato is removed from the dark and observed. In the first two pictures, you'll see the potato going through a process called etiolation. This process is modification to grow in the darkness, usually underground, which is why it does not grow leaves. Leaves would be seen as a hindrance because there's no sun present for the plant to grow to. The leaves would also be crushed underground and therefore would serve no purpose, other than a waste of the plant's time and energy, making the plant actually inefficient. Therefore, natural selection will select against it. By growing only roots and no leaves in etiolation, the plant is able to obtain the water usually lost through transpiration. It can also save energy by not making the chlorophyll, the green pigment usually seen in leaves. This allows the plant to focus on spreading its roots so that it can dig deeper into the earth and find more nutrient-rich soil and water for growth. In the beginning of the next few images, you'll see the potato tubers beginning to turn shades of light to medium green. This is because the potato is now producing chlorophyll through a process called de-etiolation. De-etiolation is when the stem elongates, leaves expand, and shoots produce chlorophyll. AKA, de-etiolation is the opposite of etiolation. This process occurs because the plant is receiving a signal, sunlight, that is processed into a response, in this case, greening. The process of de-etiolation is commonly split into three processes: reception, transduction, and response. Reception is when the phytochrome, a receptor protein located in the cytoplasm, reacts to a stimulus, in this case sunlight. The phytochrome functions as a light detector during de-etiolation. The detection of light brings us to transduction. The phytochrome activates several second messengers, cyclic GMP and calcium ions. Cyclic GMP activates the protein kinase, while calcium ions open up calcium channels. The final process of de-etiolation is response. There are two responses: transcriptional regulation and post-translation modification. Transcriptional regulation increases or decreases mRNA synthesis, while post-translation modifications activate enzyme molecules, both helping in de-etiolation and giving it the final dark green hue. This is the process of potato etiolation de-etiolation. Thanks for watching!